Chemistry class, this is the beginning of week 2 of distance learning. This is a lesson for Monday, May the 4th. And I will be putting these lessons up day by day this week. So each day look for a new lesson. You don't have to do them all one day at a time. You can wait till later in the week and do them all at the same time. The lesson shouldn't take more than 2 hours in the week to do. So here's a short lecture. We're going to get into chemical reactions. Now, chemical reactions or chemical equations are the centerpiece of the study of chemistry. Chemical equations are the recipe that shows how reactants, those are the compounds or elements on the left side of the equation, recombine into new substances called products. So you take reactants, you make products. They're essentially a recipe in chemistry of how you make different compounds from other compounds or from other elements. The one-way arrow indicates that the reaction moves from left to right. So what we're going to do in this lesson is we're just going to look at a little picture diagrams of a chemical reaction called a particulate diagram. So particulate diagrams provide a simple picture of the motion of atoms in a chemical reaction. The way that chemical compounds break apart and recombine requires advanced study of chemistry. If you take advanced placement chemistry or college chemistry, you'll study some of that. And to really get deeply into that subject, you would essentially major in chemistry in college. But all you need to do is understand that what happens is atoms or molecules smash together. They physically just smash into each other and break apart. So in order to do that, they have to have a certain amount of speed, a certain amount of energy. They have to hit each other just right. And that's how they break apart. And then once they break apart, they recombine. So particulate diagram show a beginning and final diagram of a reaction, and it might also show an intermediate state of the reactant. So I'm going to show that here. So what we have is we have one methane molecule, CH4, and 2 oxygens. Now notice that we have a balanced chemical equation. We practiced balancing equations last week, and we've done it before school was closed. So what's going to happen is somehow, we don't need to understand exactly how this happens, the hydrogens and that carbon are going to break apart, and those oxygens are going to break apart, so that what you end up is a carbon. You end up with 4 hydrogens, 4 hydrogen atoms, and you end up with the 4 oxygen atoms. They're separated. It takes a certain amount of energy. By the way, what this reaction is, it's called a combustion reaction. It's methane gas. It's the kind of gas that we have in the laboratory at school. And it combusts with oxygen, the oxygen in the air. And so you need to light a match to that, as you know. So that's giving it energy to get started. And then once the reaction gets started, it has enough heat energy to keep the reaction going on as long as you keep the flow of methane gas coming out of the pipe and as long as you keep the oxygen in the air. And then what they're going to do is they're going to recombine into carbon dioxide and H2O. So what will happen is 2 of the oxygens will combine with the carbon, 2 of the hydrogens will combine with another oxygen, and 2 hydrogens will combine with another oxygen. So what a chemical reaction is doing is it's counting atoms and molecules. It doesn't care what they weigh. It doesn't care what their volume is, how much space they take up. It cares how many of them are. It's matching up atoms. It's breaking apart molecules and compounds into atoms, and then it's matching up those atoms to form new compounds. So what it's saying here really is that you need twice as many oxygen molecules on the left as you have methane, CH4 molecules. In this case, we show 2 oxygen and 1 methane. But it doesn't have to be exactly 2 oxygen and 1 methane, otherwise this wouldn't be a very useful equation. You could have 200 oxygen and 100 methane, or you could have 50 oxygen and 25 methane. As long as you have twice as much oxygen, twice as many oxygen molecules as you have methane molecules, then this reaction will take place. So it's really giving you a ratio of how many oxygen molecules you need for every methane molecule, and then it'll tell you how many water molecules you'll get out of that and how many carbon dioxide. Now, since we're dealing in a lab and we need to deal with big numbers of molecules and atoms so that we can see them and weigh them, we think of these numbers as being moles. So 1 mole of CH4, that's 6.022 times 10 to the 23rd. 2 moles of oxygen, that's 2 times 6.022 times 10 to the 23rd, will give you a mole of carbon dioxide and 2 moles of water. So that's what a chemical reaction is, a chemical equation. It tells you how you match up the atoms and molecules, break them apart, and then recombine them to form new compounds. Okay, so I have an assignment where you'll be drawing some particulate diagrams. I'll do about 4 of them for you, and I'll ask you to do 2 by yourself, and that will be your assignment for today. All right, we'll see you tomorrow.